Perfect. Great. Thank you very much for this opportunity. This day's working out really well, I think.
So far, so good.
Yeah, and the talks have been fantastic so far. Okay, so I work for rOpenSci. I'm, for convenience, going to presume that all of you know a little bit at least about rOpenSci. I'll talk a bit more about it in a minute, just in case you don't. rOpenSci is a completely remote organization, which allows me to say I work for rOpenSci from Münster in Germany. The team is dispersed throughout a lot of the general European and American spaces. So what I'm going to talk about today is peer-reviewed statistical software and testing. But first of all, this talk will be very much about opportunities to be involved in rOpenSci in ongoing processes and development and software. And anyone who's interested in getting involved in any way at all, there are a whole lot of contact details there. The reproducible slides for this talk, the link's given at the bottom. Everybody gets copies of these slides anyway, so that's kind of doesn't matter anymore. So rOpenSci. These talks are all, if you get the original slides, hyperlinked as well. So I'm going to click on that one, which takes us then to the rOpenSci website, rOpenSci.org, which looks like this at the front. rOpenSci is transforming science through open data and software. We build software with a community of users and developers and do a bunch of stuff. So very much about software there and also open data. And if you scroll down in the website there, the second bit says interact and share, and that's all about software as well and acquiring data using our software, and this button here that says browse packages. If you click on that, it takes you to a list that says packages. Here's a description of rOpenSci's software packages. Still loading the side there for some reason. There we go. And if you scroll down here at the top, it says filters, and there's these kind of things that you can click on here, and you scroll down the page and get lists of packages and packages, and at the bottom it says that there are 16 pages, and you can go to the next one. There's no real structure to that, but that's okay. We're also working on redesigning this website a little bit to make it a little easier to navigate. Nevertheless, rOpenSci, if you look at that website, is very much about, one of their main things is software and packages. We're also about reproducibility and openness, which a few people, including Stella in the first talk today, have mentioned. And so our package database is in this thing called the rOpenSci registry, and that's completely open. Anyone can access all of the data in there. It's updated on a daily basis, and the 3 lines at the top there are sufficient, or the first 2 lines will get you the database of packages. It's a whole JSON structured table with all sorts of information about the packages. Structures a data frame, the names command there will tell you which columns are in that data frame, and the important thing here, the number of rows, is the number of packages that rOpenSci currently has, which is 386. So this is a lot of packages doing a lot of amazingly different, powerful, wonderful things, 386 of them. The packages themselves are structured into various categories. This is a frequency table of the categories from that database, and you can see that the data access category comprises the largest proportion of all rOpenSci packages. That was the original vision of rOpenSci when it was first started in 2010, 2011. So data access, data tools, data kind of themes are very prominent in the categories, as well as a number of other interesting categories for rOpenSci packages. rOpenSci, the packages themselves are mostly handled through a GitHub website. So again, everything's hyperlinked here. I click on there. It takes us to github.com/rOpenSci. You land here. This is where the repositories, where am I looking at here? Number of repositories. I don't know, I don't see it there, but that doesn't matter. Are there 426 repositories? Those packages plus a few others. You can see software review is a pinned repository. That's the main one. And you click on there and open an issue and you get the whole software review. I'll show some of that in a little bit. There's important also, we have this thing called a dev guide, development guide. If you click on that, it takes you to our development guide repository, packages, development, maintenance, peer review. This is also a book down book that looks like this. This is a fantastic resource for anybody interested in developing our packages or knowing a bit more about how our packages work. And on the left side here is the table of contents, a packaging guide, all sorts of recommendations and standards for constructing packages, for continuous integration. There are a lot of chapters in this book, a lot of detail, maintaining a package, being a package actual maintainer, including a contributing guide, which I'll get onto in a little bit. So closing that for the moment, going back to here. We also have back to the website here, which we already saw, rOpenSci.org. Now, before I highlighted that it was very much about packages, if you keep scrolling down after this browse packages that we clicked on, you get to documentation, and then you get down to the bottom where it says join our community. rOpenSci is very much about community of package users, community of package developers, connecting the different aspects of community and trying to get more people involved in the broader community. If you click on that community button, this is our main community page with a whole lot of links of different ways of contributing to and also gaining from yourself from the rOpenSci community. Very important here, this first one down here says community calls. I'm going to click on that now. Community calls work very much like what this conference today is working like. Thanks to coronavirus, I get to say that. We've always done our calls this way, and now everybody else has to kind of get on board and ask rOpenSci, how do you do community calls? Because they've always been done remotely from all sorts of parts around the world. The next community call is Wednesday, March the 18th, which is in Saturday, Sunday, Monday, Tuesday, Wednesday, 4 days. Time, it's at 9 a.m. Berkeley, California time, which translates to 5 p.m. Swiss time, German time where I am. So hopefully for most people listening, 5 p.m. this Wednesday. It's an open invitation for anybody to attend this community call. They are really fantastic. This one is going to try a new format, which is going to be an open question and answer panel conducted on Zoom, which we haven't done before. We're very excited about seeing how that goes as well. And these community calls, I always learn a lot at every one of them. So please, everybody, remember that, and you're all welcome to attend. Right, community. So moving on. What can you, as the listeners to this talk right now, as the attendees of this Saturday's remote event, do to engage with rOpenSci? I'm going to talk about two main aspects of that. One is as a package user and one as a code developer. As a package user, there are a lot of ways. One of the primary ones is our discussion board. I won't click on too many more links and go to various web pages. I think this is one of the last ones. We have this discussion board. Which is a really fantastic resource for all sorts of aspects of interacting with rOpenSci, not necessarily directly with packages, but it's definitely, there's a whole lot of categories on the side here. You can click on those and look at the kinds of things that get discussed. And it's definitely a forum where we encourage the kind of no question is too stupid to be asked philosophy. So everybody should feel free to, you do need to sign up there. You can easily sign up with a GitHub account, or I think maybe a GitLab account, and then start asking questions. And you can ask questions like, is there any way of doing this thing in R that I never thought about and I don't know if it's possible? Can you do it? Can you help me do this? Can you help me do that? It's very much about community help, community feedback, and constructive practices. So that's one of the main ways. That discussion board also has a use case category. So rOpenSci is very much about actively extending our community to other people. So I'm going to do that live right now. Julia, thank you very much for your talk that you just gave before, that I was really excited about hearing, that was scheduled for later, but it happened beforehand, which is fantastic because now I get to say, you mentioned in there one rOpenSci package, OSM data, which you showed some graphs of. That's perfect to be submitted as a use case to the discussion board for rOpenSci. If you would be so kind as to do that, we'd greatly appreciate it. It would help to promote your work among the rOpenSci community and also help us by showing that our rOpenSci packages also get used in talks for important events like the remote conference of SatRday Neuchâtel. I'm also really proud because the OSM data package that Julia talked about happens to be one of the packages of which I am a maintainer. So that's my package. Thank you, Julia. Love to talk more about it later. You can also participate in community calls, as I said, this Wednesday, and there's a whole lot of other ways listed on the rOpenSci page. As a developer, you can read the rOpenSci developer guide. I showed you what that looked like already. Now I will click on that one more time and it'll take straight to this contributing page, what you can do to contribute. There's a whole lot of list of different ways. And all I want to talk about here is this why contribute to rOpenSci packages. There's a beautiful statement here that says, starting at this point here, contributing to R packages allows you to make things work the way you want by adding some functionality to your favorite package. Can lead to opportunities and allows you to learn about package development. I really like that phrase. I think that really encapsulates all of it, that by contributing, you can help make sure that our packages can do what you actually want. It goes on at the bottom also to say, we strive to make contributing a social experience and we are creating social infrastructure through a welcoming and diverse community. So to reiterate again, our rOpenSci is very much about community. The infrastructure that we are constructing is primarily We see it as not software, but social infrastructure. So as a code contributor, you can read the development guide, you can use our packages, give feedback in any way whatsoever, any way that you see fit to contribute to the packages, opening issues on GitHub, making pull requests, or even getting motivated enough to think, well, I've actually got an idea for my own package, and you might want to start developing your own package. You can use the rOpenSci discussion board to reach out for all sorts of help there and questions, and ultimately down the line, maybe have a package at a sufficiently developed state that you think, I'm ready to open a pre-submission inquiry on the GitHub rOpenSci review site. Now, going back to the list of categories of there are our categories. When you submit a package for pre-review means you ask, do you see this package as suitable for review under rOpenSci? And you'll get a binary yes, no answer. Hopefully it'll be a yes answer, because we'll say, yes, that fits within one of our recognized categories and we're happy to proceed to review. We'll close the pre-review issue. Please resubmit and open a full review issue. These issues come with all sorts of templates where you have to fill out checkboxes and answer a few preliminary questions about your package. Now, what you'll notice here is that R is actually a language for statistical computing. I think the official name is something like the R language for statistical computing. There's no statistics within those categories, which is an interesting situation. Now, if you click on this link here, and get the original slides, it will take you to an example of what happens if you try and submit a statistical package to, this is the software review issue of rOpenSci. So somebody in the middle of last year opened this issue, submitted the package, and relatively quickly got this response. This looks like a really cool package. Unfortunately, because it's more of a statistical analysis package, rOpenSci are not currently able to provide review. However, it is an area we are actively working on, so perhaps try again in the future. Not a very satisfactory answer in this case, but if you click on that link, it takes you to a blog post. rOpenSci also has a blog, which is really fantastic. You're free to subscribe to it, check out the regular updates to that. It has all sorts of amazing things in it, from which I also learn a lot. Hopefully everybody here will be motivated to also look at the blog and learn a lot through it. Very quickly, under here it says rOpenSci has $678,000 US from the Sloan Foundation to expand software peer review. What this means is these three bold aspects: new tools to manage software peer review process, better training and documentation, and most importantly, a new focus on statistical software. And it says down in the text here, we'll be setting up a review board and we'll be working with the review board, this bit here, to develop a set of agreed upon standards for statistical package implementation and testing. So, the Alfred P. Sloan Foundation gave them money so that we can start peer reviewing statistical software. Two questions. Why hasn't this been done before? Why haven't we or somebody else done this before? Because it is actually really, really difficult, as I'll indicate in a moment. Why are we doing it now? Because it's really important. As said, R is a language for statistical computing, and an awful amount of modern data science practices are effectively statistical computing. So peer review is really important. Also, during Stella's talk, there was a question raised about whether journals have issues with R because R comes with no warranty. The answer to that is yes, they do. And that's one of the issues that we hope to work on through this development of peer review for statistical software. Now, we're not the only ones working on this. There's also a project called the R Validation Hub. Very quickly, click on that link just to show you. Here's the front page of this. This R Validation Hub comes exclusively from the pharmaceutical industry. And you look down there, it's about biopharmaceutical software. And they have a list of participating organizations within this R Validation Hub, attempting to develop a system for validation or certification of R packages. We will be working together with the Validation Hub. They're doing it in their exclusive domain. We're doing a more generalized model. They have 44 organizations. We are one organization. They have relatively little money. We have, compared to them, quite a lot of money and around 1.5 full-time staff. So we're going to work together with these two different approaches. We'll be co-developing our approaches together and see where it goes over about the next 1 to 2. By the end of next year, this should be pretty much all up and running. To return to the comment in that blog post that said, develop a set of agreed upon standards for statistical package implementation and testing. So I said this is really difficult. We have so far devised a list of categories of statistical packages for which we'll develop standards and testing. This is our initial attempt at a package categorization. You can imagine how difficult it's going to be to devise standards for all of these different categories, and also a lot of packages fulfill multiple categories. What are standards for a package that is an educational package for machine learning, which also produces visualization? How do you devise standards for those sorts of things? This is the challenge that we are now faced in this project, which we'll be doing. Rather than now go on and talk about standards, I'll talk about the slightly easier aspect of it, which is going to be testing. We're also going to have to test the packages. So for the rest of this talk, very briefly, I'll just check how much I've got to go. Doing okay. I will talk about testing of software in a very concrete framework now with a bit of code and stuff like that. But in order to ultimately show how this project, as well as rOpenSci in general, hopefully can encourage anybody listening here to participate within the rOpenSci community through, in this example, developing a new approach to the concept of testing within R packages. So testing can be looked at a lot of ways. One of the ways that you can look at testing is as a distinction between concrete testing and property-based testing. Concrete testing is arguably what's done in almost all testing cases, including almost all R packages, where you have a function and you write a test for it that says, I'm going to input a value of 43.7 to my function and I expect the answer to be 6. The inputs are very concrete, the outputs are very concrete. In contrast to that, there's another approach to testing called property-based testing. Instead of inputting 43.6, you say, I'm going to input a real floating point number, and I expect the output to be an integer or something like that. And you talk about the properties of inputs and outputs rather than concrete testing. Concrete testing, historically, is where all testing started. In R, this is the main way that the teststat package is used to write very concrete tests. In Python, it has this PyTest framework, and the benchmark in this context is a computer language called Rust, which has concrete testing inbuilt into the very structure of the language and the compiler itself. Property-based testing has been developed very notably in Python through something called the hypothesis. It's more than just one package, it's a framework, a testing framework for Python. Rust has, in this case, followed the example of Python. Rust usually leads the way and everybody follows Rust, but in this case, Hypothesis has done an amazing job of developing a property-based testing system for Python, and Rust has followed that. There is no line for R down the bottom there because there currently is no property-based testing available within R. What might property-based testing look like? So this is where I dive into code just for a couple of minutes here. R has this documentation system developed from Oxygen, which is a C++ system developed for R. So they stuck an R in front and called it Roxygen. And this enables you to document your functions in the same place as the code's actually written. So here's a definition of a function. And when you write a package as a package maintainer or author, you then write these lines generally. If you use Roxygen, you don't have to, it's an option, but it's a convenient way to do it. And you put this hash dash format at the front, and then you define a parameter here and you say there's a parameter X and you describe what it is, a parameter Y, a parameter Z. This function returns some value and the export thing says export it out to the workspace so that users can use the function. Then you can run a command that translates all of these Roxygen formatted commands into a manual entry. So when people look up the help for your function, F, they see what you wrote in those lines. So Roxygen makes documenting functions very convenient in R. The current package is called Roxygen 2, and it's extensible and adaptable to all sorts of frameworks. And there is also, for example, a package called RoxyTest, which enables tests, only concrete tests at the moment, but to be specified directly in function documentation. So back to the question at the top of this slide, what might property testing look like? This is an example of what it might actually look like. Now, I'll step out of here for a brief moment and point out that this is not yet implemented. This is one idea that we've got at the moment for this project on statistical software and evaluating new systems for setting standards and for testing software. By the end, I'll hopefully show you the advantages of this. So this does not yet actually exist in practice. What I want this to be is an example of the sorts of things that we're going to be working on, and an invitation for anybody who's interested to please contact us, get involved at any point along the way, help make rOpenSci better, help make our community better, and help make ultimately the entire R ecosystem better by please helping out in any way you see fit with the development of these kinds of tools. So property-based testing with Roxygen kind of documentation. The slide before had these 5 lines of standard Roxygen entries. Now we've added a few more down the bottom. This says, given that this input X, it defines what it is. This is an integer. So we assume that that's an integer. We assume Y is a numeric value, Z is a character. And here's a test written in there. We expect that the result of this function F is an integer, and we expect that this function F returns one single value. It has a length of 1. So that is property-based testing. We haven't said anything about the value that X or Y or Z takes, merely the class of object that is input here. And we expect those kinds of results. The actual implementation of property-based testing in reality wouldn't be like this. This would be a very inefficient way to do it. But in simple R code, what you effectively do is just run a bunch of random trials where you randomly generate values of X as integers. So you've got this ceiling function, which rounds numbers up, and it's a uniform random number, maybe between some really big negative and really big positive number. Y is a floating point value, so it's just that. And you just run this function a heap of times, and you put it in a try catch clause here so that you try and catch any errors and then dump those errors and analyze those. So what you're doing here is randomly trying to find if there are any errors in the function for values that the authors of the function didn't think about putting in there. So property-based testing tests responses to ranges of input values, not concrete input values. Property-based testing can also test responses to structures. The difference between the previous code like that and this code is that we've now put in this length thing, which say is some random integer up to 1,000,000 or so. And now we are saying X instead of one value is a vector of values up to about 1,000,000 different values. Y is still one single value. And we're throwing that at our function F and seeing what happens. So now we're testing responses to variable structures of input values, not just the actual values themselves, but the structures, the lengths of this vector now differ. So the authors get clever in that regard, and they think, well, of course, in R, any number is a vector itself. A single number is simply a vector of length 1. So they've rewritten the code and presumed that the length of X is less than or equal to 10. And this is the authors of the code then saying, this is explicitly what we've coded in here now. And given that the result of the function is then stuck in this variable called res, we expect res is silent. So nothing happens when you run the function. There's no errors, there's no warnings, there's no messages. It just returns a value and everything works as long as X is less than or equal to 10. That's a great way of specifying property-based testing. Now, let's pretend that the authors of that code accidentally wrote less than 10 instead of less than or equal to 10 in the code. I can come along as a user of the code and add to these lines of property-based testing documentation within the actual code and say, given that the length of X equals 10, because I ran this code, and the result is this, I expect that res is silent because that's what the authors of the code said here, but I want to now report that res is an error because obviously they typed in less than 10 when they meant less than or equal to 10 in their code. So what I'm doing here is reporting a bug with this keyword report, using exactly the same grammar as the tests. So one of the advantages of property-based testing is that bug reports can then be written using exactly the same grammar as tests. Obviously, by extension, feature requests can do the same thing. Again, these ones at the top are exactly the same. And I simply say here, given that viz is true, we've got no idea what this viz thing is. It's just something that I've just defined here. I report at the moment, if I put that parameter viz into the function, I get an error. And instead of in a bug report here, where I report here that res is an error, I request that inputting this parameter produces interactive graphical output. So feature requests can use the same grammar as tests. Bug reports can use the same grammar. Feature requests can use the same grammar. And the really important thing is that either way, bug reports or feature requests become direct pull requests and direct code contributions to the actual software. So this is a really convenient way to get users directly engaged with the software itself. And this is known in a lot of ways, including by RStudio, who put a lot of effort into getting people directly involved in their code. This is one of the best ways to improve your code, is to encourage people to actually become actively involved in looking at the underlying code of the software that they're using. And this will offer, when we implement it, hopefully, a fantastic way to get people directly involved in using the underlying code behind our packages. In conclusion, there is a lot of prior work involved in property-based testing, especially within Python around this hypothesis package. I said, if you look at these slides in the version from the link, all of these things are hyperlinked and you can have a look at all the different Python packages and stuff like that. At the moment in R, there are no attempts to develop property-based testing. A couple of exceptions have been tried a few years ago, but seem to be dormant now. And the final link down the bottom there is a framework that is being looked at very seriously within a lot of language domains for translating these kinds of expressions here. I request that this produces interactive graphical output into a form that makes machine sense, that actually tells you what to do as a coder based on verbal input. So there is a lot of prior work that we're hoping to build on to develop a property-based testing for R. And the message that I want to convey here is that this is just one example of something that we hope may come out of this project for testing and building standards for statistical software that will really help to build community. Last slide. As I said, this is definitely an open invitation for everyone and anyone to help, to contribute to rOpenSci, to use our packages. Julia, please feel absolutely free to open a use case on the discussion board for rOpenSci and link your talk there. People will then watch your talk when they see it. Please contribute, anyone in any way whatsoever. We are hopefully opening up more and more ways for people to contribute. And this has just been an example of one of them that we're working on. And the important one for the broader context of this talk is that soon enough, it will be possible for rOpenSci to also peer review, curate and host packages for statistical routines, which is the core of what R was always intended to be. Okay, that's the end of my talk. Thank you very much.
Thank you so much, Mark. We've just learned a lot. I didn't know property-based testing before, but yeah, so you also mentioned something at the very beginning that our rOpenSci is right now flooded with questions like how do you do community calls? And I was in fact one of those people that asked Stephanie Butland. So kudos to her for helping me out and explaining to me how this all works. We don't have questions from the audience, but I'm sure there are questions. So I propose that we head over to the rooms. So Julia will be in room A, Emma will be in room B, and Mark, you will be in room C. And I suggest that everyone is heading. You can also swap between the rooms, and each of us organizers will be there as well. And also one note, some of the speakers, they have code in their presentation. So if you want, you can also share a code repository. I think Julia just mentioned that she will prepare something. But we are just sharing the slides, but if you want, you can also share something else. And I think there is, no, wait, there is one question actually. Yeah, Audrey is asking how widespread or clustered is the use of rOpenSci? Yeah, that's a good question, because I think this also varies across the world.
And I don't have any answer to that question.
Maybe I can say that one reason why we wanted to have you or someone else from rOpenSci speak is because I think Switzerland could use a bit more of rOpenSci. Yeah.
Yeah. We certainly aim and aspire to be as non-clustered and as widespread as possible. Measuring degrees of clusteredness and geographical spread is a very fraught endeavor. We don't do at the moment.